A powerful solar storm can mess up life on Earth in a catastrophic way. It can leave huge regions of our planet without power, disrupt communication and navigation satellites, damage power grids and data centers. Scientists warn that the next major solar storm could become one of the most devastating natural disasters. And the question isn't if it happens. The correct question is when. And the scary part? This kind of weather doesn't happen in Earth's atmosphere at all. It starts 93 million miles away on the Sun. When the Sun becomes active, we can feel it on Earth. This activity can mess with satellites, GPS, radio signals, and even parts of the power grid. Scientists usually group space weather into three main types: radio blackouts, geomagnetic storms, and radiation storms from the Sun. Each one has a different effect on Earth. Radio blackouts happen when the Sun sends a powerful burst of energy, aka a solar flare, our way. When that energy reaches Earth, it hits the upper atmosphere and disrupts the way radio signals travel. Geomagnetic storms are different. Sometimes the Sun launches enormous clouds of superheated gas into space. These eruptions are called coronal mass ejections. Imagine billions of tons of solar material blasted away from the Sun at a speed of millions of miles per hour. If one of those clouds comes across Earth, it slams into our planet's magnetic field at full speed. The result is a massive geomagnetic storm. We've already seen some serious space weather recently. For example, in May 2024, the strongest space weather event since 2003 hit Earth. GPS systems went through massive disruptions. The US agricultural industry was hit hard, all because modern farming needs satellite navigation to work properly. As for the infamous 2003 event, it completely cut power in parts of Sweden and South Africa. You might be wondering, what will happen if we get something even bigger? Scientists decided to figure out what a true worst-case space weather event might look like. Now, worst case doesn't mean a once-in-a-million-year disaster. Planning for something that rare isn't super useful. Instead, researchers focused on events that could realistically happen once every 100 to 200 years. Rare, but not impossible. When a strong geomagnetic storm hits Earth, it doesn't just affect space. It can actually generate electric currents in the ground too. And since power lines are excellent conductors, those currents can get inside the electrical grid. It's like extra electricity getting suddenly injected into a system that wasn't designed to deal with it. If the currents are strong enough, they can overload parts of the grid. Safety systems may automatically shut sections down to prevent damage, potentially leading to massive blackouts. Whole regions might stay without electricity. But losing power isn't even the worst part. The extra current can also damage transformers, those massive machines that help move electricity across the grid. Some of these transformers weigh hundreds of tons and can take months or even years to replace. This means that even after the storm is over, parts of the electrical network may still remain damaged for a long time. The power grid on Earth isn't the only thing at risk. A serious space weather event will first mess with satellites hundreds of miles above our heads. And we depend on satellites far more than most people realize. They help us navigate, forecast the weather, communicate with relatives and friends all over the world, and track ships and aircraft. During a bad solar storm, many of those satellites could run into serious trouble. One problem is radiation. When the Sun throws large amounts of energetic particles into space, those particles can slam directly into spacecraft. Over time, they can damage electronics and slowly wear down solar panels, shortening a satellite's lifespan. During an especially powerful event, some satellites could fail completely. But there's another huge problem. A solar flare can actually heat Earth's upper atmosphere. When that happens, the atmosphere expands outward and becomes slightly thicker at altitudes where many satellites orbit. The change is tiny, but for satellites, it matters a lot. Imagine riding a bike on a smooth road, and then suddenly someone pours a thin layer of mud over it. You can still move forward, but you'll slow down faster than before. Something similar happens to satellites. The thicker atmosphere creates extra drag, and that drag slowly pulls satellites into lower orbits. If they lose too much altitude, some spacecraft can fall back into the atmosphere and burn up. And it's happened before. In 2022, solar activity caused Earth's atmosphere to expand right after a batch of Starlink satellites was launched. Around 40 of them couldn't maintain their orbits and eventually re-entered the atmosphere. But during a real worst-case solar storm, the situation could become way more dramatic. It could also prevent us from tracking satellites and increase the risk of their collisions with space debris. The next problem is radio signals. Right now, they're constantly passing through the air around you. Your phone, GPS, Wi-Fi, aircraft communications, ship navigation systems, emergency services, all of them depend on radio waves. And a bad solar storm can mess up many of those signals. Solar flares produce bursts of radio energy, and sometimes those bursts become so powerful that they drown out weaker signals on Earth. It's kinda like trying to hear someone whisper while a jet engine is running nearby. None of this means that a giant solar storm would send us back to the Stone Age. Even a worst-case event probably wouldn't be a Hollywood-style apocalypse. But it could create a chain reaction of problems. Satellites could fail. GPS could become unreliable. Flights could be cancelled. And parts of the power grid could be damaged. That's exactly why scientists spend so much time studying space weather. And now, they might have to come up with a pretty cool idea for protecting Earth from powerful solar storms. They proposed something called storm wall. The idea is simple. What if we don't just wait for solar storms to hit and deal with the damage? What if we weaken the solar storm before it reaches Earth? The idea is based on Earth's magnetic field. Our planet is surrounded by a giant magnetic bubble called the magnetosphere. It's like an invisible shield that helps protect us from charged particles coming from the sun. Researchers noticed that Earth's atmosphere already helps strengthen this shield. Tiny particles escape from the atmosphere and interact with the outer edge of the magnetosphere. So scientists decided to try to boost that process on purpose. Their plan involves 6 spacecraft orbiting Earth. Each spacecraft would carry materials like barium or lithium. If you release them into space, sunlight would charge those materials, turning them into a cloud of plasma. Plasma is basically a gas whose particles carry electric charges. The sun itself is mostly made of plasma. The idea is that those artificial plasma clouds would form near the edge of Earth's magnetic shield, and when a solar storm arrived, the plasma would help absorb, redirect, and weaken some of the storm's energy before it reaches Earth. According to the team's simulations, the system could reduce the strength of a serious geomagnetic storm by 50%. That would be a really great result. A storm that's cut in half would mean less damage to satellites, fewer communication problems, fewer GPS disruptions, and less stress on power grids. Of course, this is still just a concept. Nobody has built the storm wall yet. Nobody even knows for sure whether it would work exactly as planned in the real world. But the researchers say that the physics behind it checks out. And apparently, modern rockets can indeed launch the equipment we'd need for such a mission. There's just one problem, and it's money. Building and launching 6 spacecraft wouldn't be cheap. Plus, once the material is released into space, it's gone. You can't collect it, refill it, or use it again. The researchers believe that the mission would use about as much material as a dozen large tanker trucks. That's why the price of a truly massive solar storm could be exorbitant.